morning, one and all. Myself, Sreevani, working as an assistant professor in the Department of Electronics and Communication Engineering in Institute of Aeronautical Engineering, Dundigal, Hyderabad. So, in the today's lecture, we are going to learn about Poynting vector and Poynting theorem in electromagnetic waves and transmission lines. So, Poynting vector. So, in this particular lecture, we will learn about Poynting vector and Poynting theorem. So, before going to describe about Poynting theorem, let me introduce the Poynting vector. So, what is the notation for Poynting vector? Now, what do you mean by a statement related to this Poynting vector? So, firstly, the statement regarding this Poynting theorem is given by here. The energy stored in an electric field and the magnetic field means in general we are representing this electric field intensity is with E, it is a vector, hence it is denoted with E bar, and magnetic field intensity vector is denoted with H bar. Vector notation, we are supposed to write it as a letter followed by over bar. So electric field intensity vector as E bar and magnetic field intensity vector as H bar is transmitted at a certain rate of energy flow. Means the energy stored in an electric field as well as the magnetic field, and it is transmitted at a certain rate of energy flow which can be calculated with the help of the Poynting theorem. Means by using this Poynting theorem we can measure the energy or rate of energy flow which is to be transmitted in the, and this can be calculated with the help of this Poynting theorem. So in order to measure the energy which is to be stored in electric as well as magnetic fields and can be considered as a certain rate of energy flow, and this can be calculated with the help of this Poynting theorem. So and it is denoted with P. Here this P bar is also a vector. So the power density is given by here P bar is equal to, it is a product of E bar into H bar, right? So where E bar is denoted with electric field intensity vector and H bar is to be magnetic field intensity vector, right? So in general we will represent the power, means it constitute the two following parameters as voltage and the current. Right? As in the circuit theory, we are representing the power means V and I, it is the multiplication of V and I. Coming to the field theory, where V is replaced by electric field intensity vector as E and the magnetic field intensity vector as H. Hence, P bar is given by E bar into H bar. This is not the into one, means rotation of a vector we are supposed to consider this here. Right? So P bar, the power density is in general expressed in field theory is given by P bar equal to E bar into H bar, where P bar is called as the Poynting vector. Right? So vector notation we are supposed to represent with a letter or followed by over bar. So P bar is equal to E bar into H bar is said to be Poynting vector. Okay, so now to derive this mathematical equation for this Poynting vector, we are using the Poynting or average power density. Right? So Poynting theorem is based on law of conservation of energy in electromagnetism. Why? Because P bar is given by E bar into H bar, means the energy which is to be stored in electric fields along with the energy which is to be stored in the magnetic fields we have to consider over here. So Poynting theorem is based on law of conservation of energy in electromagnetism, right? And the direction of P bar indicates instantaneous power flow at that point. Means in general we have discussed the uniform plane waves case. If you are assuming x, y and z bar directions are given as like this, then if you are assuming electric field is in the x direction and the magnetic field is in the H direction, the wave which is to be propagating is in the other directions of these two, x and y, is to be considered as P bar, right? Where this P bar, E bar, H bar are mutually orthogonal. Means The angle between E and H is exactly 90. Similarly, H and P is 90. P and E is 90. Right? So the Poynting vector P bar, electric field intensity vector E bar, and magnetic field intensity H bar, or three are orthogonal to each other. Orthogonal means mutually perpendicular to each other. Right? So this is about Poynting vector. To derive the mathematical equation for that, see, first, according to the definition of this Poynting theorem, the net power flowing out of a given volume means integral V is equal to the time rate of decrease in the energy stored within a volume minus ohmic power dissipated. Ohmic power dissipated means, according to the Maxwell's equations, what is the formula for ohmic power? That is J equal to sigma into E. As it is analogous to the Ohm's law, that is V equal to IR, nothing but in the fields, that is J equal to sigma into E bar. Okay, so according to that statement, firstly, if we are assuming electric field is in the x direction, that magnitude is given by Ex and the unit vector direction as Ax bar, hence it is given by E bar, right? So vector E bar can be given by here Ex into Ax bar, and H bar is given by Hy into Ay. Why we have considered x and y directions means, just now we have seen, initially, in order to define this electromagnetic wave or uniform plane waves, we have to consider one of the directions assumptions as initially electric field is in the x direction and the magnetic field is in the y direction. Right? So E bar equal to Ex into Ax bar and H bar equal to Hy into Ay bar. Okay? Then P bar equal to. So previously we have defined the vector P bar is nothing but it is the multiplication factor between the electric field intensity vector E bar and the magnetic field intensity vector as H bar. Okay. So P bar is nothing but E bar is given by here Ex into Ax bar into Hy into Ay bar, which is given by Ex into Hy. Then unit vectors multiplication is given by Ax bar into Ay bar. Since Ax bar into Ay bar is nothing but Az bar. Why? Because cross product representation of two adjacent unit vectors resultant will be the third one. Right? Suppose if you are considering three unit vectors as Ax, Ay, Az, so cross product between two adjacent vectors x and y will be the other one as third, z. Suppose if we are multiplying these two in the opposite directions, Ay into Ax, then it will be minus Az. Right? So already this and all already we have discussed in the fundamentals of electromagnetic waves or prerequisites of electromagnetic waves and the transmission lines. Right? So P bar equal to Ex into Hy into Az. Right? So it will be given by here Ex into Hy into Az bar. This is nothing but P bar. Poynting vector is given by Ex into Hy into Az. Right? Or simply we can write it as P bar is nothing but Pz into Az bar. Right? This is the way we are assuming the electric field intensity vector as E bar and magnetic field intensity vector as H bar and Poynting vector P bar are mutually perpendicular to each other. Right? Hence, here E bar is given by Ex into Ax, H bar is given by Hy into Ay, then resultant vector is given by here Poynting vector is expressed in terms of Z, that is Pz into Az, where Ex, this Hy and Pz are the magnitudes of XYZ directions, and Ax bar, Ay bar, and Az bar are the unit vectors in the respective directions of E, H, P as X, Y, Z. Okay. So from these three equations, we can say that P bar, E bar, H bar are mutually perpendicular to each other, or simply we can say that electric field intensity vector E bar and magnetic field intensity vector H bar and Poynting vector P bar are orthogonal to each other. Right? So the angle between any two will be exactly equal to 90. Okay. Then the electric field propagates in free space is given by. In order to express the directions along with the directions of a Poynting vector, we have considered here the electric field which is to be propagates in free space is given by. So in general we have considered electric field vector EA bar is given by EX into AX bar, right? So along with the propagation characteristics, if you express the electric field in terms of its direction, means the electric field which is to be propagates in free space is given by. So this already we have discussed in the fundamental cases of electromagnetic wave equation case, that is E bar is given by its magnitude as Em and the cos omega t minus beta z into Ax. This is the propagation direction as Z, and initially we are assuming electric field is in the x direction, right? So omega is said to be angular frequency of that wave, and beta is the phase constant, z be the propagation direction. And omega t minus beta z means here we have considered forward direction wave, right? So E bar is given by here Em cos omega t minus beta z into Ax bar, right? Then in the medium, the ratio of magnitudes of E bar and H bar depends on the intrinsic impedance as eta. Means in general we know that intrinsic impedance eta is given by it is the ratio of E to H, electric field intensity vector E to magnetic field intensity as H, right? So from this we can write H bar is given by Hm into cos omega t minus beta z into Ay. Then we have assumed initially according to the uniform wave or electromagnetic wave direction XYZ. So electric field is in the X direction, magnetic field in the Y direction, and the propagation vector is on the Z direction. Hence, this H is expressed as in the terms of Y direction as H is equal to Hm cos omega t minus beta z into Ay. Right? Suppose if you want to express the Hm means magnitude of the magnetic field intensity vector, H is expressed in terms of intrinsic impedance and the electric field intensity vector, means from this if you write the expression for H, then it is given by E by eta, right? So if you substitute Hm by this value means E by eta, and here we have considered the medium as free space medium, right? So H bar is equal to Em by eta naught cos omega t minus beta z into Ay. This eta naught is given by intrinsic impedance of the free space medium. Nothing but eta equal to E by H is equal to, is given as in general propagation characteristic equation, that is j omega mu by sigma plus j omega epsilon root over. So if we substitute for a free space medium, we know that sigma is assumed to be 0. If we substitute sigma by 0 in this equation, j omega mu by j omega epsilon root over. These two gets cancelled. Root over mu by epsilon is left out. Right? For a free space medium means we are representing this mu and epsilon with mu naught and epsilon naught. As we know, these two are to be substituted the values as 4 pi into 10 power minus 7 by 8.854 into 10 power minus 12. Then these two are approximately equal to 377 ohms or 120 pi ohms. Right? So intrinsic impedance of the free space medium, as we know that its analysis on all we have discussed in the case of electromagnetic wave propagation characteristics or uniform plane wave characteristics. Right? So H is given by here Em by eta naught into cos omega t minus beta z into Ay, where eta naught is said to be intrinsic impedance of the free space medium, and mathematically we can consider its approximate value as 377 ohms or 120 pi ohms. Okay, so then according to the Poynting theorem, what it states that P bar is given by E bar into H bar, right? Again, what is E bar here? Em cos omega t minus beta z into Ax. And what is h bar here? This is Em by eta naught into cos omega t minus beta z into Ay, or Hm cos omega t minus beta z into Ay. Okay. Then, according to the Poynting theorem, that is, Poynting vector is given by P bar is equal to E bar into H bar. Now substitute in place of E and H by those two, then 2 are given by here. P bar is equal to, so E bar, Em cos omega t minus beta z Ax into Em by eta naught cos omega t minus beta z into Ay. This total thing is substituted in place of E bar, and this total thing is substituted in place of H bar. Why? Because P bar is given by E bar into H bar. Okay, so if we substitute E bar by Em cos omega t minus beta z into Ax bar into Em by eta naught cos omega t minus beta z into Ay, right? So now Em into Em becomes Em square by eta naught cos of omega t minus beta z cos of omega t minus beta z. Cos theta into cos theta becomes cos square theta. In place of theta, here we have omega t minus beta z. And as we know that the cross product representation of cross product representation of two adjacent vectors resultant will be the third one as Ax bar into Ay bar is equal to Az bar. Hence, Ax bar into Ay bar is given by Az bar. Right? So, P bar is nothing but Em square by eta naught cos square omega t minus beta z into Az, and here can be power density now, and it is measured as omega per meter square, right? And the power passing particular area is given by, so power is equal to power density into area. So general this power can be measured in watts, and it is given by power density means watts per meter square into this area can be measured in terms of meter square. This meter square gets cancelled. Watts is equal to watts, means the power which is to be passing through a particular area is measured by power is equal to power density into area, right? So in general we can define the power density as power per unit area, that is given by power density, right? In general it is measured in watts per meter square. Okay, then to calculate average power density. So in order to calculate this average power density, we have considered, see, to find the average power density, let us integrate power density in the z direction over one complete cycle, and it is divided by a period, that is total period t of one complete cycle. So total period of one complete cycle means, suppose if we consider one complete cycle as this 0, this is t by 2 and this is t, right? So one complete cycle means total period is given by t, then average power density in general we are supposed to consider as P average is given by 1 by t integral 0 to t Vm square of t dt. This is the general formula in order to calculate average power density Pm square. Okay, so that's why it is given by P average is equal to 1 by t integral 0 to t Pm square, nothing but previously what we have got P average is nothing but Em square by eta into cos square omega t minus beta z into dt, right? So Em square by eta, if you are integrating this one with respect to t, then Em square by eta t are to be considered as a constants. Then we can write Em square by eta into t as out of this integration. Then P average is equal to Em square by eta t integral 0 to t 1 plus. Why? Because cos square theta. The formula is given by 1 plus cos 2 theta by 2. So in place of theta, here we have omega t minus beta z. Hence 1 plus cos 2 theta. 1 plus cos 2 into omega t minus beta z as theta by 2 into dt. right? So now integration of this one with respect to t. So 1 by 2 is given by here t by 2 plus sine means integration of cos is given by sine 2 omega t minus beta z by 2 into 2 omega. Then it becomes 4 omega and limits are given by 0 to t. Right? Why? Because integral 0 to t, this is integration result will be given by t by 2 plus sine 2 into omega t minus beta z by 4 omega, then 0 to t. If we substitute in place of t by t, then it becomes t by 2 plus sine 2 omega t minus beta z by 4 omega plus. Means if we substitute upper limit as t, then it will be up to this as the t by 2 plus sine 2 omega t minus beta z by 4 omega plus. If we substitute lower limit as 0, then in place of t, if we substitute 0, then it becomes sine 2 beta z by 4 omega. Okay, and this should be, means already in the formula itself we have a sine 2 minus 2 beta z is left out, and in the to substitute lower limit we are supposed to consider it as negative. Upper limit minus lower limit, then negative is there, and sine of minus theta becomes minus sine theta, then minus minus becomes here it will be plus. Okay, then p average is equal to em square by eta into t, then t by 2 plus sine 2 omega t minus beta z by 4 omega plus sine 2 beta z by 4 omega. Right? So now to derive this average power density, firstly we have to consider P average in general formula. In that you just substitute Pm square by that formula which is to be obtained in the previous case as P average equal to 1 by t integral 0 to t Em square by eta cos square omega t minus beta z into dt. Then Em square by eta into t are to be considered as a constant. Then integration with respect to t means cos square of this function is as a variable. Now to integrate this one cos square theta, we just apply the formula as cos square theta equal to 1 plus cos 2 theta by 2. Now cos 1 plus cos 2 omega t minus beta z by 2 into dt is this one. Now after integration we have to get the value as t by 2 plus sine 2 into omega t minus beta z by 4 omega, and substitute limits as 0 to t, where upper limit is capital T and the lower limit is given by here 0. So in the first case if we substitute upper limit as t by 2, and for lower limit case minus 0 means its value is approximately equal to 0, then plus. Again in this case if we substitute upper limit as t, then sine 2 omega t minus beta z by 4 omega plus sine 2 beta z by 4 omega. If we substitute lower limit as 0, then it will become sine 2 beta z by 4 omega. Now upon simplification this will be given. Means let omega t equal to 2 pi. Suppose if you are considering one complete cycle, means that phase must be considered as here 0 to pi and 2 pi. Hence that omega t is given by 2 pi. Right? So let omega t equal to 2 pi. Now P average is equal to em square by eta t into t by 2 plus sine 4 pi minus beta z by 4 omega plus sine 2 beta z by 4 omega. Okay, then and em square by eta t into t by 2, then if we substitute in place of this one sine 4 pi minus theta, it becomes sine theta, then minus sine theta, so minus sine 2 beta z by 4 omega plus sine 2 beta z by 4 omega, and this gets cancelled, plus sine 2 beta z by 4 omega minus sine 2 beta z by 4 omega gets cancelled, and em square by eta t into t by 2 is obtained. Right? So then em square by eta t into t by 2 is left out, then these two gets cancelled, then t and this t gets cancelled, then P average is equal to half into em square by eta. Right? So half into em square by eta, or this can be given in terms of general equations as P bar equal to E into H bar, or if you substitute eta by E by H, then from this, if you want to write the equation for E equal to eta into H, or from this, if you want to write the equation for H, then E by eta, right? So, in general, in this case, E into, if we substitute H by this E by eta, then it becomes E square by eta. Or if you want to express in terms of E by eta into H, then it becomes P equal to eta into H square. Okay. So, in general, the power equation P equal to V into I, or V square by R, or sometimes I square into R. So, in the similarly, here also V and I is replaced by E and H, and V square by R is M square by eta, and HM square by HM square into eta. So, in place of R, here we have intrinsic impedance as eta, right? So, average means we are supposed to consider as 1 by 2 that function. Hence, average power density is given by 1 by 2 Em square by eta, and it is measured in watts per meter square. Okay. So, now to derive this one, average power density, we must consider first the in general average power density formula, that is P average is equal to 1 by T integral 0 to T Pm square of T dt. Right? So Pm square is nothing but is the multiplication factor of P equal to E into mH, and these two are to be multiplied by Em square by eta into cos square omega t minus beta z into this function Az. Why? Because E is in the x direction, H is in the y direction, then cross product between x and y is given by z, then depending upon that it is to be obtained. Now this value need to be substituted in place of this, then our integration, then resultant will be obtained as average power density is nothing but P average is equal to 1 by 2 Em square by eta, right? Where eta is said to be intrinsic impedance of the medium and Em square is magnitude of the electric field intensity vector, right? Density. Now, next one, important one is Poynting theorem. Till now, what we have discussed is Poynting vector. How mathematically we can express that pattern Poynting vector, then relation between E, H and P. Then we have derived the equation for average power density, right? Now, important one is Poynting theorem. So, to derive the mathematical equation for this Poynting theorem, let me define statement regarding this Poynting theorem. So, Poynting's theorem states that rate of energy transfer per unit volume, rate of energy means which is to be stored in the electric fields as well as the magnetic fields. Both we are supposed to consider. So, it states that rate of energy transfer per unit volume from a region of space equals the rate of work done on the charge distribution in the region plus the energy flux leaving that region. So flux leaving that region means we are supposed to consider divergence theorem, right? So where divergence theorem gives the relationship between surface to volume integrals. Okay. Then as we know that closed surface integral is A dot ds is equal to integral v del dot v del dot a dv, right? So this gives us the divergence theorem, right? So Poynting theorem states that the rate of energy transfer per unit volume from a region of space which is to be equals that the rate of work done on the charge distribution in the region plus the energy flux leaving from that region. And this energy can be transported from one point to the another point. Means that particular point, one point is said to be here, transmitter is located, and the other point is said to be with a receiver. Means the energy must be transferred from transmitter to the receiver in a electromagnetic waves case. by means of electromagnetic waves. EM stands for electromagnetic waves. The rate of such energy transportation can be obtained from Maxwell's equations. In order to derive the mathematical equation for this Poynting theorem, we need to use the two Maxwell's equations which are to be considered from the time varying fields or electromagnetic fields. And one is from the Faraday's law, and it states that del cross E bar equal to minus dou B bar by dou T. And from the Ampere's circuit law, that is modified form of Ampere's circuit law, del cross H bar is equal to J plus JD, where J is said to be conduction current density and JD is said to be displacement current density, right? So in order to derive the mathematical equation for this Poynting theorem, we need to use the two Maxwell's equations which are to be obtained in the case of time varying fields. Okay, so now del cross E bar equal to, so what is this equation? From the Faraday's law, from the Faraday's law, del cross E bar equal to minus dou B bar by dou T, and which is equal to minus mu into dou H bar by dou T. Why? Because as we know that the relation between B and H, as B is said to be magnetic flux density and H is said to be magnetic field density, then B bar is equal to mu into H bar. Okay, so B bar is nothing but magnetic flux density, and mu is permeability of that medium, and H bar is magnetic field intensity, right? So from this relation, B bar equal to mu into H bar, then if we substitute B bar by mu into H bar, then del cross E bar can be expressed as minus mu into dou H bar by dou T, right? This is the one of the Maxwell's equation which is to be derived in the time varying fields or electromagnetic fields. Next, one more Maxwell's equation in the time varying fields as modified form of Ampere's circuit law, and it should be considered as del cross H bar equal to J plus JD, JC plus JD, where JC is said to be conduction current density, or it is also known as point form of Ohm's law. Point form of Ohm's law. Okay, so what actually Ohm's law? V equal to IR, and it is analogous in the field theory is nothing but J equal to sigma into E, where J is said to be conduction current density, and it is analogous to current in the Ohm's law, where sigma is conductivity and it is analogous to resistivity in that Ohm's law, and E is analogous to voltage. Hence, the point form of Ohm's law in the modified form of Ampere's circuit law is given by sigma into E bar plus JD, that is displacement current density. JD is given by dou D bar by dou T, right? As we know that D and E relation is D equal to D bar equal to epsilon into E bar, where D bar is electric flux density, epsilon is permittivity of the medium, and E bar is electric field intensity, right? So now if you substitute D bar by epsilon into E bar, then sigma into E bar plus epsilon into dou E bar by dou T. Okay, so del cross H bar is equal to sigma into E bar plus epsilon into dou E bar by dou T, right? Then dotting both sides of the above equation with E gives us, means firstly we have to consider, in order to write the final mathematical equation for Poynting theorem, firstly we have considered two Maxwell's equation which are to be considered from the time varying fields or electromagnetic fields. Those are del cross E bar equal to minus mu into dou H bar by dou T, and del cross H bar is equal to sigma into E bar plus epsilon into dou E bar by dou T, right? So now consider these two are the two Maxwell's equations, and dotting both sides of the above equation with E gives us, E is nothing but means del cross H bar is equal to sigma E bar plus epsilon into dou E bar by dou T. Consider this is the equation. Now from that, if you are going to apply dotting, means dot product with E from the above equation, then it gives us E dot del cross H bar. So already del cross H bar is there. We are considering dotting with E. Hence this equation becomes E bar dot del cross H bar is equal to sigma E bar square plus, means already sigma into E bar is there. Again we are multiplying this with E, and so it becomes E bar square plus E dot epsilon into dou E bar by dou t. So already this is the term is exist. We are considering dot with E. Hence E dot epsilon dou E bar by dou t. Right? So in order to simplify this equation, we have here a vector field. Some of the identity is given by, means, but for any vector field A and B. So in general, vectors means we are representing with A and B are the two fundamental vectors. Then from that vector identity, we have got one of the relation as del dot A bar plus B bar is equal to V dot del cross A minus A dot del cross B. Okay. So here A and B are also two vectors, and these two can be written as del dot A bar cross B bar equal to B bar dot del cross A bar minus A bar dot del cross B bar. Okay. So as we have related this, A is nothing but magnetic field intensity vector as H, and B is nothing but electric field intensity vector as E, right? So now if you substitute A by H and B by E in this equation, how you going to write that equation? Del dot E bar cross H bar equal to B bar is nothing but H bar dot del cross E bar minus A bar is nothing but B is nothing but here E bar into del cross H bar minus H bar dot del cross E bar. Okay. So from this, what we have got, the similar term which is there in this equation means what? E bar dot del cross H bar means this is the term we have got. So in order to write this equation, E bar dot del cross H bar is equal to, how are you going to write this equation? Take this term H bar dot del cross E bar into this term, then it becomes H bar dot del cross E bar plus del dot E bar cross H bar. Okay. So from this vector identity, this is the equation is to be obtained. Now by applying vector identity to that the previous equation as A equal to H and B equal to E, then those two equations are to be written. Then from that, E dot del cross H plus del dot E bar cross H bar is equal to what we have got in the previous equation, that is sigma, means by dotting, then finally we got equation as sigma into E square plus E dot epsilon into dou E by dou t, right? Remember here electric field intensity vector electric field intensity E and magnetic field intensity H both are vectors. Okay. As in general we are analyzing that equations with A and B. Okay. Then E dot del cross H bar plus del dot H bar cross E bar equal to sigma E square plus epsilon E dot epsilon into dou E by dou t, right? So from this, H dot del cross E means in this equation H dot previously, from that equation we have got H dot del cross E equal to H dot del cross E equal to H dot del cross E. What is that? From the Faraday's law, what is that equation? Del cross E bar equal to minus dou B bar by dou t and minus mu into dou H bar by dou t. Right? So del cross E, if you substitute del cross E by this relation minus mu into dou H bar by dou t, then minus mu by 2 dou by dou t h square. Why? Because if you are expanding this equation, then resultant will be, we have got minus mu by 2 dou by dou t into h dot h. Right? In the similarly, that equation also can be written as epsilon equation, means from this del cross h equation, means E dot del cross h bar can be written as E dot del cross h j plus jd, nothing but E dot sigma into E plus dou epsilon dou E by dou t. So if we simplify the equation as with dot, then that is the case also. We have got equation 1 by 2 epsilon into dou E square by dou t. Right? Similar to that, this del cross E bar. So minus mu by 2 dou h square by dou t, means in place of this equation we just substitute this form, means minus mu by 2 dou h square by dou t minus del dot h bar cross E bar, these two equal to, on the RHS we have sigma E square plus 1 by 2 epsilon into dou E square by dou t. Right? So upon simplification, means we can separate here this mu by 2 dou h square by dou t and this 1 by 2 epsilon into dou E square by dou t as separate. Why? Because this half epsilon E square and half mu h square are to be considered the energy densities or energy just to be stored in electric as well as magnetic fields. Right? So in order to separate those two are by rearranging the terms and taking the volume integral on both sides of that equation. Means we can separate here first this term. So integral V, so by taking volume integral, hence integral V del dot h bar cross E bar into dV, this term with respect to volume, hence integral V del dot h bar cross E bar into dV equal to, and minus dou by dou t, take this term into this side and multiply with negative, then becomes minus dou by dou t, consider in the both the equations as 1 by 2 epsilon E square in this term and 1 by 2 into mu h square from this term. Right? So minus dou by dou t integral V 1 by 2 epsilon E square plus 1 by 2 mu h square into dV minus. Now we are applying sigma into E square to the volume integral, then integral V sigma into E square dV. Right? So after simplification, this equation, we are rearranging the terms with respect to the energy densities and ohmic laws as well as this resultant term to get Poynting vector. So in order to write the Poynting vector, we just consider del dot h bar cross E bar into dV as separate, and these two are the energy densities which are to be in the electric as well as magnetic fields, and the last one is ohmic law. Right? So from this, applying divergence theorem to the left hand side of the above equation. See previously what we have in this equation, LHS part, integral V del dot h bar cross E bar into dV. So what actually divergence theorem? See, the divergence theorem gives us integral closed surface integral S A dot ds is equal to integral V del dot A dV. Right? So in place of A, here we have E bar cross H bar. Hence, then closed surface integral S E bar cross H bar into ds is equal to this term. Then minus dou by dou t, then integral V 1 by 2 epsilon E square plus 1 by 2 mu H square into dV minus integral V sigma into E square dV. Right? So this is the final mathematical equation for the Poynting theorem. As we have seen, the fundamental definition of this Poynting theorem gives us the total power leaving the volume, nothing but is entering the surface function, that is total power leaving the volume is equal to rate of decrease in the energy, rate of decrease, that negative sign resembles as that the rate of decrease in the energy stored in electric fields. This is electric fields and this is related to the magnetic fields, right? Rate of decrease in the energy stored in electric and magnetic fields minus ohmic power dissipated. So ohmic power, as we know that according to Ohm's law V equal to IR, this ohmic power dissipated in the uh, field theory, that is given by J equal to sigma into E, right? So this is the statement which is given for the Poynting theorem. It states that the total power leaving the volume is same as that of the rate of decrease in energy stored in the electric and magnetic fields minus ohmic power dissipated. So this is the exactly statement which is given for the Poynting theorem, and mathematically we can express that as closed surface integral S E bar cross H bar ds is equal to minus dou by dou t integral V half epsilon E square plus half into mu H square dV minus integral V sigma E square dV, right? So energy stored in the electric fields is given by half into integral V epsilon E square dV, and energy stored in the magnetic fields is given by half into integral V mu H square dV. So these two are to be considered as, so we have to write the energy which is to be transmitted from transmitter to the receiver in the field theory. We are calculating with the help of the Poynting theorem, and mathematically we can express that equation as like this, and the statement is given for that is total power leaving the volume is same as that of the rate of decrease in the energy stored in electric as well as magnetic fields minus ohmic power dissipated, right? So this is the way we have derived the equation for Poynting theorem. So what we have learnt in this particular lecture as firstly Poynting vector. Poynting vector we have learnt, that is P bar is expressed as E bar into H bar. Then after that we have learnt average power density, that is P average is equal to half into Pm square by eta. Then after that we have learned one statement is given by power is equal to power density into area, right? And finally, we have derived the mathematical equation for Poynting theorem, right? So, according to the statement of this Poynting theorem, we know that the total power leaving the volume is equal to the rate of decrease in the energy stored in electric as well as electric and magnetic fields minus ohmic power dissipated. And to calculate the energy present in the electromagnetic fields with the help of this Poynting theorem, we can measure. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.